Today we're going to continue finding area, and we are still going to try to slice horizontally and vertically. There's books on a shelf, books in a stack that become infinitely thin. Let's just do our default for finding the area bounded by the graph of y equals 9 minus x squared and y equals the line containing -1, 8, and 3, 0. We know area under the curve is the integral from a to b of f of x to x. And I can just take the top area, the area under the parabola, and subtract off the area under the line. And just go from -1 to 3. Let's see what that looks like if we imagine that this is a bunch of books on a shelf that is sliced vertically. So the books on a shelf slicing strategy would have delta x as the delta variable. So that's the direction that books are going to be getting thinner. So the area of the slice is length times width. I'm going to set the delta x to be the length, and so this height of the rectangle will be the width. Notice that we have two different y values. The width is the distance between these two functions. So I have this y value and these two y values from the same x value. So I've got, say, y1 down here, but I've also got y2. Now, y2 is from the function. The function doesn't know about this line. This parabola doesn't know about this line down here. So y2 goes all the way from the parabola down to the x-axis. So we notice that the width is always the parabola minus the line. And this is going all the way across. So parabola minus the line, parabola minus the line, parabola minus the line, parabola minus the line. And even this one, parabola minus line, but they're both 0. So our width is y2 minus y1. And our length is delta x. But this is not good. We can't integrate integrate y with respect to x when y is a function of x. If x and y are independent variables, then everything is fine. But y depends on x, so I can't have this kind of setup. But y2 is the parabola, so I can replace y2 with 9 minus x squared. So I can write the area of the slice as 9 minus x squared minus y1, which is, I need to clean this up. It's even bugging me now. It's going to be 8 minus 2 is 6 minus 2x. And so this is exactly the definite integral that we would have set up if we were just going by area. If all we had was area under curve is integral from a to b, we just integrate the parabola from -1 to 3, integrate the line from -1 to 3, subtract the area under the line from the area under the parabola. It's important to notice these things because when we come up with methods for doing things, we got to make sure that they're backwards compatible with our intuition about how things should work, especially when those methods have worked in the past. We have to say, does this still fit with what we had set up before? And so we can see that it's going to. So the area total, this is where we switch to a definite integral. We add up all such slices into a Riemann sum. Let the number of books go to infinity, so they become infinitely thin. And I want to clean this function up a little bit. We got 9 minus 6 is 3. Minus and minus is plus 2x and minus x squared. Our discrete delta x becomes a continuous dx. Then the last thing we'd have to do is go and look for the values of x where we have one of these books. And the books start here at -1 and end when x equals 3. So integrate from -1 to 3. Questions? At this point, we're going to do the integral by hand. And in that, so we're going to use our hand to grab our calculator and then math 9, 3 plus 2x minus x squared with respect to x from -1 to 3. So 32/3, so 10 2/3. Any questions? When we set up integrals this way, I want to know that the definite integral is set up. That's what we want to focus on. This is why when the part of the problem is going to be to set up a definite integral, we're going to use a machine to calculate the value. I have a quiz that I forgot to assign because it's on my list of quizzes, but y'all's list of quizzes. But one of the things would be to integrate a polynomial. That's when we're not going to use a machine because I want you to know how to integrate functions. I want you to know that the integral is 3x plus x squared minus 1/3 x cubed. But I'm going to ask that separately because the point of this problem is to not find out if you can integrate a polynomial. The point of this problem is to find out if you can set up a definite integral for a specified quantity. Setting up the integral is the problem. The only reason I'm going to ask you for the exact answer or the answer to 5 significant figures is so I could quickly determine if your integral is set up right. So if I look at the end of this problem and I see 10 2/3 like I expect, then I only have to casually glance back at your integral. I look at the integral, I check that the endpoints are what I expected the endpoints to be. I made sure that your delta x became a dx. And then I go to your setup up here where you were setting up the slice and see if everything's labeled properly. I look at the problem backwards. And so when you have 10.667 over here, I know that I'm expecting to not find a lot of problems leading up to that. When I see the 10.667 over here, and I see an integral that has nothing to do with anything that's going on over here, then I just give you a 0 and say, where did that integral come from? So don't put BS integrals. Expect me to just look at the 10 2/3 at the end. Agreed? Because I will wait till I find you amongst a group of your friends and I'll say, oh, hey, excuse me. Yeah, I just wanted to ask about this integral that you gave me. See right here? And I'll try to make it as embarrassing as possible. I'm just kidding. That's just because I taught high school, so you learn certain patterns. And apparently in high school, one of the things to do is to be mean to the children when you're the adult. I guess what I'm saying is that high school is a pretty fucked up place. Any questions? Yes. The Y2 and the Y1 are based on where the slice hits these functions. So Y1 is going to be where the slice interacts with the line. And Y, when we have X and Y on Cartesian coordinates, Y is always the distance from the X axis up to the point. That's where we get the Y2 and the Y1. They're from the two functions. When you're labeling things, you're always going to want to label your slice with its length and its width. Then you're going to want to go and label your X and any relevant X's and Y's. Remembering that your X is always measured from the origin horizontally, and Y is always measured from the origin vertically. I put them way out here because I didn't have space to write them in here. Yes. Yeah, so the width is the distance between the parabola and the line. So if there was another slice, the width would be from the distance from the parabola down to the slice. Here's another slice from the parabola down to the line. So at all these points, we're just going from the parabola down to the line, stacking up books like that. Or not stacking books, we're putting books on a shelf. Any questions? So here's books on a shelf. Let's use the stack of books strategy. And let's see why this particular function is going to cause us problems with the stack of books strategy. So in a stack of books strategy, our delta variable is going to be a delta Y. And so our width is going to be a horizontal width. So the delta Y is the stack of books getting thinner. So our delta variable is going to be a delta Y. The width is always just going to be perpendicular to the delta Y. So the area of the slice. It's an area, so it's always going to be length times width. And our length will be delta Y, but our width will be the horizontal distance from one end to the other, so from left to right. Now let's look at this slice that I've drawn here. Once we've labeled the dimensions of our slice, the length and the width, and identified the delta variable, I should label any relevant X's and Y's. Here's a Y coordinate, and it corresponds to two X coordinates. X1 from the line and X2 from the parabola. Notice that for this particular book, the left side is the line and the right end is the parabola. So X1 is the line and X2 is the parabola. Everybody see how that book is sitting between the line and the parabola? That's where that slice is. So we all see this book. One end is the line, the other end is the parabola. What's wrong with this representative? I could just use this one the whole way up, right? All set to integrate from 0 to 9. Clearly the answer is no. You can tell by the way that I'm acting. So why can't I just use this, x2 minus x1? It looks like w is x2 minus x1. So isn't that how it's going to work? W is x2 minus x1. I'd have to rewrite my parabola to solve for x. But if, let's see, y is 9 minus x squared, I think we found out last time that x was plus or minus the square root of 9 minus y. And so it looks like the x2, since that's where x is positive, so I'll just use plus square root of 9 minus y. Minus the line x1. Now, if I just have to turn this around, y equals 6 minus 2x. So that means that y minus 6 is equal to negative 2x. That means x is negative 1/2 y plus 3. So the width is just going to be the parabola, positive square root of 9 minus y, minus the line. So we'll use the positive square root of 9 minus y. And we'll subtract 1/2 y plus 3. So I'll just use this width and integrate where we have all these y's. And y goes from 0 to 9, so that's it. I'll integrate this from 0 to 9, right? Let's take this, use it all the way up. Because it's always the left side is the line, the right side is the parabola. So why am I not just going to integrate this expression from 0 to 9? Down here is where y is equal to 0. And up here is where y equals 9. So shouldn't I just use this expression from 0 to 9 on the y's? More relevantly, more accurately, I could ask, why am I not just going to integrate this function from 0 to 9? How come I haven't written down the integral from 0 to 9 of the square root of 9 minus y minus negative 1/2 y plus 3? Fill in some details. Why would it be inappropriate to integrate this function from 0 to 9? Yes. Yes, perfect. This is not the left and the right between y equals 8 and y equals 9. After we get to y equals 8, the left and right change. The line is no longer part of the picture. I can get a partial, and it would be appropriate to integrate this from 0 to 8. But that would only give us the first 8 units of this stack. The left and right ends of this book change their definition once we get above 8. Notice that if I draw a slice where y is more than 8, we never even touch the line. The line is not part of it. Now, for the width in that top section, the left is the negative square root, and the right is the positive square root. So when I do x2 minus x1 for y greater than 8, the width is just going to be 2 times the square root of 9 plus y. Sorry, 9 minus y. So we'll have to have a second integral from 8 to 9. And for there, we'll integrate to square root of 9 minus y, dy. But we only need to use this definition for the top 1 unit. So we use our calculator, find out what this is, and find out how much this is. And then the area total will be the bottom part plus the top part. In this case, slicing as a stack of books is inconvenient because our left and right changed partway through our stack. It was parabola minus line from 0 to 8. Then it was one side of the parabola minus the other side of the parabola from 8 to 9. Now, once again, remember the point is not finding the area because we already know that the area is 10 2/3. The point is understanding the process and how the process changes if we look at problems differently. Comments? Is everybody okay? All right, let's take a look at this sheet. So what we have is the face of this shape is a parabola, and it's the same parabola projected through some height or length, whatever you want to call it. So let's say that the base of the parabola wait, which one of these is the front parabola? Is it the higher one or the lower one? Is this mailbox facing up or pointing down from this view? Which one is the front? Is it this one because I wrote it first? But I drew the line, so everything's made out of plexiglass. It's hard to tell. We can only see the seam. Or is this one in the front? Is this one going up or is this one going down? Down mailbox. Up mailbox or down mailbox? Which one do you see? Trick question. It's a neither. It's a two-dimensional projection of what we're looking at. We're just pretending that it's three-dimensional. Just like when we were playing 3D games on our computer, it's not three-dimensional, it's like two-dimensional. We're just tricking ourselves into believing that it's three-dimensional. But it's all a lie. It's flat. It also doesn't matter. I just want to take a parabola and I want to project it through some length. Because we want to talk about volume. Volume is cross-sectional area multiplied by length. So let's say that this is clearly, it was the top one, that was the front. And let's say we can describe this parabola because it has a height of 9 and a base width of 6. So let's just say it's the parabola y equals 9 minus x squared. And we're going to project this parabola back into the paper. Or is it coming out of the paper? Or is it shoved back into the paper? Coming out of, oh man. No, I don't even know. Let's suppose that it comes 10 units out of the paper because I don't want to get stuck in the desk. Because that would be really inconvenient. I'd have to like take the whole desk apart just to get my mailbox out. So let's imagine it comes out of the paper and it comes out 7 units. There are a few ways that we could slice this. One that makes sense and another that's going to be really weird and very forced, but will help us practice calculus things. All right. So there are 2 ways we could slice, just like we had before. We could have sliced on a shelf, vertical slices, or we could have slices in a stack, horizontal slices. So the slices on a shelf will be, one of the slices will be a parabola. And our delta variable will be a delta H because it's coming straight out the page. So one way we could slice this is by just reading it, finding the area of that parabola and multiplying it by 7. Our delta variable will be here. It's not a delta x or a delta y, so I'm going to call it something else. Let's say delta h. And now you realize at the beginning you were being deceived. You were giving choices, but neither one was correct. It's not coming. It's not a mailbox coming out, pointed down or pointed up. It's sitting on the ground facing up and coming directly out of the page. So it's not even in mailbox shape. It's in trash can form. So for this calculation, if I could just find the area of the face, the parabolic face, and multiply by 7. So the volume multiply, we'll take the volume at the area of the parabolic face multiplied by the height. This is because when we slice this vertically as slices on a shelf, the slices are all the same size. The slices are all the same size, so we get to use multiplication. Because that parabolic face is always the same size, I can find out whatever that area is just multiplied by the height. Our factors are constant, so we get to multiply. Questions? Let's slice it the other way. Let's slice it horizontally. Oh, I got to draw another one. Let's slice horizontally. If we slice this horizontally, we're going to get rectangular slices. So if instead of thinking of slicing vertically, if we slice horizontally, we're going to end up with rectangular slices. Everywhere I slice this horizontally, we're going to see a rectangular. Down at the floor, we got this rectangle, and the rectangles just get smaller until they decrease down to a line at the top. So the volume of the slice is just going to be length times width times height. In this case, our height can be delta y. Because we're making a stack of slices. So the slices have to start getting infinitely thin. That's how we determine our delta variable. Notice that the length of all these slices is going to be the same. They're all going to be 7 units long. So because this is always 7, I could say that the length is 7. The thing that changes is the width. So notice that all these slices have the same shape, but different areas. That's why we're not going to be able to do just multiplication. I can't multiply some rectangle by the height. But at least all the slices are rectangles. They didn't change shape partway through our solid. If the task is just to find the volume of this thing, the best strategy would be to find the area of the parabolic face and then just multiply by 7. But that would be ignoring half the ways to do the problem. And we should never ignore half the ways to do the problem. It might be that there's something else about this solid that doesn't vary front to back like this. It could be that the density is higher at the bottom and the density decreases towards the top. If that's going to be the case, then I can't use this slice at all. It doesn't help us, because I'd be trying to find the mass, but the density is variable on that slice. And if we want to use multiplication, we have to slice where things are constant. Any questions? So there might be reasons that we have to slice horizontally. It could be very simple reasons, like the homework problems tell you how to slice. Even though you're like, oh, dude, it's the volume of a cylinder, pi r squared h. But like we mentioned yesterday, the point is not to find the volume of a cylinder. The point is to give you a cylinder, have you slice it horizontally, which is really weird, to make sure that you come up with the same volume that you get from that pi r squared times h. Any questions? How's everybody okay? Can you tell which volume I'm not going to be calculating today? Probably this one, because I haven't written down, okay, let's go, let's draw. I haven't drawn any of that stuff. Can you guess what I'm going to ask about tomorrow, first thing? I just haven't stipulated the risk that you're in, the jeopardy that you're in. Because if you can't collectively tell me what the volume of the solid is, I'm just going to flunk all of you on the spot. I'm just kidding. I'm not do that. That would be cool. All right, so I want you to find the area in both directions. And make sure they come out the same. If they don't come out the same, then one of them is wrong. This is not an agree to disagree situation. Most situations are not an agree to disagree situation. Sometimes arguments don't have a gray area. You know what I mean? But with 2, if you do this problem both ways, as different as they are, and they come out the same, you're going to feel more confident that you must be correct. So I go, look, I got the same thing to 5 significant figures. Must be onto something. You know what I mean? All right, that's going to do it for today. Find this volume, these 2 different ways. I'll see you all on tomorrow. Everybody have a good day, and thanks for playing.